Hi, I'm showing you the execution of two programs. The first is a UDP server, and the second is going to be a UDP client. And the key idea of the two programs collaborating together is that the client will be able to receive a large document in the form of a file, text file, and it's one you've probably seen before in Pharos. It's to do with the history of the Norman invasion of Britain in 1066, a famous event. And we know, first of all, that the, the, the protocol, the UDP protocol, is not reliable. And the two programs I'm going to show you actually uh, give you a measure of reliability in the way in which I'll try and outline in a moment or two. So I'm just going to try and find um, the second file amongst all the Java files I've got here. It might take a few moments. You'll have to bear with me. In fact, what I can do is to... Well, okay, the client is in this area here, so I'm going to select this workspace. I'm going to launch the IDE environment, and let me just check. I've got a server on the left hand side, and what's going to appear on the right hand side is the client. And the those among us who only joined relatively recently, um, let me just see, will have missed the presentations within this course on reliability, the design of a reliable protocol. And one of the themes of that presentation, and I think we covered that in some depth, was that the way in which we get reliability is intuitively. Um, if I talk to you and you don't actually understand what I'm saying, you'll ask for me to say it again. Alternatively, if I send you some information and you don't acknowledge that by saying, okay, well, okay, give me something else to give me some more information, then I'm going to again resend the information in the form of a packet of data again, and hopefully in the end you will actually receive it and you'll be able to acknowledge it. And one theoretic possibility is that when I send you some data, I'm going to set in a little alarm clock, which gives the system enough time for me to send you a packet of data and for you to return an acknowledgement to you. And if I don't get an acknowledgement back within that time, I'm automatically going to send you the data again. So I'll show you what's going on in this program, because first of all I'm going to start the server up. So I'm going to start that running, and then I'm going to start the client up, and you'll see that it gives me an IP address, dotted quad notation. It's a local address. That's fine. And what the program's going to do is there's an expectation that I'm going to send a request to the server and it's a very, very simple request. It's literally the word hello, and watch very carefully in um, both of these areas, area 1 and area 2. So the client is actually just sending the server a request in the form of a simple message, hello. So I'm going to press return here and see what happens. And the server is actually telling me when it's sending a packet of data to the client. And it's also telling me when it's waiting for an acknowledgement. And the presence of hello here is an indication that an acknowledgement has been received. Therefore, the task of the server is to simply send another package to me. And on the client side, um, let me see if I can just make this window a bit bigger. Probably not. Well, it's faithfully uh, reproducing each single line that it's received from the server. And, remember the server might be transmitting from the moon's surface, or from outer space, or from New York, it doesn't really matter where. So it's quite an interesting technology. And we've seen something very similar um, when we had a TCP client and a TCP server. We could do exactly the same thing, knowing that TCP is actually going to give us automatically reliability. Because if TCP loses a packet, then automatically at some point the lost packet will be recreated. And if I don't get an acknowledgement back, I'm going to send the packet again. And again, if I get an acknowledgement for something I know that I've already sent twice, I'm going to actually send the missing packet again. And I've shown you sort of diagrams indicating how that's actually done. And we spoke about the receipt of 3 duplicate acknowledgements last week and the week before, so that's quite important. Well, anyway, the only thing for me to say is that we could wait here for about a quarter of an hour at least, whilst the file's being transferred, because it's very inefficient to send a chunk of data out and before sending the next chunk of data out, wait for an acknowledgement. Now, it would be much better if I could send, say, 100 chunks of data out and relax if then I receive a cumulative acknowledgement for all the data that I've sent out. It's far more efficient. I can sort of send out one packet of data after another very, very, very quickly indeed. Anyway, the key thing here is to remember that we're not using TCP. So what we're doing is to use UDP sockets, which are quite different from TCP sockets, and we're using explicitly using datagrams to transmit data via a socket. And using a socket is connectionless. The best I can do is when I create a socket is to specify an IP address and a port number, and it doesn't really matter whether there's anybody listening out for that transmitted packet. No exception is going to be thrown. My job as a UDP socket is to simply send out data, and I don't care if it gets there or not. Hopefully it will. I'm doing my best to get it to its destination. And one other thing I'd like to just tell you about is that if I want to send data out through a UDP socket using a send, I mean, if you look through this file, um, I'm using the socket, the name of the socket is DS, and I'm using a method called send, and the response is going to be a datagram. And before I can send a datagram, I've got to build it in ways that I'll talk about today. And similarly, if I want to receive a datagram, I mean, if I'm the UDP client and I want to receive a datagram, I've got to prepare for the data's arrival. In other words, I've got to create an empty array and then perform a receive operation on what in effect is a sort of an empty datagram. And once I've received the datagram, once I actually receive the datagram, I can extract the data contained in it, and I can extract the sender's address and port number. So you can see that this is, in my mind, a very successful little program. Very inefficient, but it works very well. And you'll get every single line from this rather large history document. Okay, so I'll finish that, and hopefully this is sort of helpful. And of course, I can give you the code if you're interested to actually perform this operation of sending a file. And if you do a little bit more practical programming, you could actually request a specific file that's stored on this particular server. So, for example, I could ask for file A rather than file Z, and it'll be transmitted to me. A second development, which we'll only touch on next week, is that we can actually make the server multi-threaded. In other words, it can respond to a packet that's actually in effect saying send me file B or C or D or E or F. And the concurrent aspect, the multi-threaded nature of the server, is that the server can actually handle sending data out to each of those clients. Okay, so I'll finish there. Hope it's been worth your